Hello, this is Tyler Beamer, Haywood Community College. This is an instructional math video for DMA 040. This video is in regards to Module 4, Section 1, Introduction to Variables and Algebraic Expressions. So a variable is a letter that represents all the numbers fitting a pattern for some specific expression or equation. A better definition that I like to use for variable is a variable is a letter or a symbol that represents an unknown value, something that we do not know, and in most cases something that we're trying to solve for. The variables that you see most frequently are x, y, z. You can also see variables t, s. T is most often used for time. If you get into physics, you can be looking at s quite frequently, which would be position. In our case for this class, we're pretty much going to be looking at x, y. Those are the ones that you'll see most frequently. So building on a variable, an algebraic expression, that's a combination of numbers, variables, and operation symbols. So let me give you a few examples of what an algebraic expression could look like. So this could be an algebraic expression, 4x plus 2. It fits the definition. We have a combination of numbers, letters, and operation symbols. Here we've got addition. 4 and x, if they're written right beside each other, that implies multiplication. So that's an example of an algebraic expression. Another example could be something like this. So it could get more complex, right, where you can have multiple terms with exponents. You could even have something that's got multiple variables in it. So algebraic expressions come in all different shapes and sizes. There's lots of different varieties in the types that you can see. And evaluating an expression means that we replace a variable in an expression, such as these, with some number, and then find the value. So if we look at each of these expressions, I don't know the value of x or z or y, any of the variables in these expressions. So I cannot determine the value of these. If I knew the value of any of these variables, then I could then follow the order of operations to simplify and find the value of the entire expression. So let's take a look at doing that. So here's an example. We want to evaluate 7 plus 3z when z equals negative 3. So here's our expression, and here is the value of z. So we want to replace z with negative 3, since that's what we're saying it is equivalent to. And then we want to follow the order of operations to complete this. Now, keep in mind your order of operations, which is parentheses or any kind of grouping symbols. So it could be parentheses, it could be brackets, even a fraction bar or a square root could be a grouping symbol. So take care of those first. Inside the grouping symbol, follow the order of operations. Next, you got exponents. Okay. Then you have multiplication, division, and these are done left to right, whichever comes first. And addition, subtraction is the same way. Left to right, whichever comes first. Okay, so in this particular problem, we don't have any parentheses other than these, which just denotes the multiplication. So we want to do the multiplication. So 3 times negative 3 is negative 9. And I bring the 7 down. Notice I don't write that as plus minus. I just use subtraction. So we want to eliminate double signs. And then 7 minus 9 is the subtraction, which gives me negative 2. So the expression would be equal to negative 2 if z was equal to negative 3. Okay. Let's look at another one here. So 2 times x minus y for x equals 8, y equals 4. So we substitute 8 in for x, 4 in for y, and then we want to simplify, so we follow order of operations, do the parentheses first, then multiply to get 8. Okay. Let's take a look at another one, something a little bit more complex here. Let's take a look at something like this. And let's make our variables x equals 1, y equals 2, z equals 3. So this is probably not going to work out great, but that's okay. I just wanted to show you an example that was a little bit more difficult than the ones we just did. So notice you've got a fraction here. So when you want to complete a problem in which you have a fraction for your expression, complete the numerator separately from the denominator, and then you'll do the division at the end. So the numerator is 1 squared plus 2 times 2 minus 3. So we do the parentheses, follow the order of operations inside the parentheses, so that's going to be 4 minus 3. So we get 1 squared plus 1. And then we do the squaring. So 1 squared is 1 times 1, which is 1. So 1 plus 1 gives us 2 as the numerator. Then compute the denominator. So 2 cubed minus 4 times 3 plus 1. So 2 cubed is 2 times 2 times 2. So that's 8. Then we do the multiplication next. Then we do the subtraction first, because that comes first as I go through the problem left to right. So subtraction is before the addition here, right? So I do whatever comes first left to right. So 8 minus 12 is negative 4. Negative 4 plus 1 is negative 3. Okay, so I've got my numerator, I've got my denominator. So now the final step, put the number for the numerator over the number for the denominator. If I could divide these, I would do that. Now this is not going to be divisible. Obviously negative 3 is not going to go into 2, so we're going to keep that as a fraction, negative 2/3. Okay. Alright. So this is something that's going to be an ongoing focus in the module, is translating written words into the language of math. So here are some key words that describe different operations. So these words here describe addition. These words describe subtraction, multiplication, and division. So we want to work on being aware of those so that when we see them, we can use those. So if I look at an example of this, write an algebraic expression, use x to represent a number. So 5 decreased by a number, right? So 5 obviously is just the number 5. Decreased by means subtraction. That was on the list, right? So go back to the list. Decreased by. And by a number, so a number that's unknown, so that's our variable x. So 5 minus x. Okay. B, the quotient of a number in 12. So what's the word quotient tell us? All right, quotient is division. So quotient of a number in 12, so that would be x, which is a number, divided by 12. So x over 12. You could write that in fraction form. You could also write that in division form with the division symbol, either way. Okay, so hopefully this gives you enough information to get started. If you have any questions, as always, please email those or stop by the office. Have a great day.